Welcome back to our channel. In the previous class we have just stopped the problem with the calculation of moment, and now we have to calculate check for depth. Always the depth whatever we are providing should be always more than the depth required. So how can we calculate the value of depth required? Means using the formula of mu equal to 0.138 FCK BD square, we are going to calculate the depth required. And we are going to get the value as 0.138 using XU max by D equal to 0.48, and this is the maximum value of maximum neutral axis depth for Fe415 steel. And already the question also we were given that Fe grade of steel is Fe415. So based on this value we are going to calculate these values. And in the previous classes also I have just defined the values of different grades of steels. And now already the value of mu is 155.49 into 10 power 6. Already we have calculated in the previous class. So FCK is 20 and breadth is 210, and now I have to know the value of depth required. So after some manipulations I have got the value as 517 mm, but the depth whatever I provide is 460 mm. It means depth required is always, it means depth is more than the depth required is more than depth provided. It means the section will undergo failure. See, for any section always depth required should be less than depth provided. But what I got in this problem, depth provided is less than the depth required. So this won't be satisfied. So now again I have to redesign the section because the section may undergo deflection. So for that purpose again I am going to redesign the section by considering L by D as 10. As in the previous case, L is the span length, and already now I have to calculate, now I am again redesign the section. So again I have to redesign the effective depth of the section. Now effective depth is going to be now effective depth of the section is equal to 500 mm, and in the same way we are going to assume breadth. As in the previous case, breadth equal to D by 2. As done in the previous case, capital depth is nothing, capital A, that is nothing but total depth of the section equal to effective depth plus effective cover. So effective cover previously we have assumed it as 40. So now I got the depth as 500. Now again effective span. As in the previous case, effective span we can consider using IS code 456 in two ways. That is, L effective is effective span plus support width center to center of support width. So among these two values, whichever is lesser, that is considered as the effective span. So now effective span is going to be 5.5 meters. So again load calculation. So dead load calculation. In the previous video already I have written the formula for dead load. So using that formula I am just calculating the values. So total load. So total load W. Now I have to convert that into factored load. For converting that into factored load, I have to multiply with factor of safety. That is nothing but factored load. Now I have to calculate bending moment. So W is 43.56. So again I have to check the depth. So in the previous case also we have checked the depth. So there the section is failed. And now again I am going to check the depth, and the formula for checking depth is M equal to 0.138. Already M is 160 point. FCK 20. Width of the section 250. So here required depth is 482. 482.94, which was nearly equal to 485. So whatever depth I provided is so the depth whatever I provide is 500 mm. So the required depth value is less than provided depth. So the section is going to be the safest one. So now I can just design the section by providing AST. The remaining part of the problem I am going to follow up in the next video, and you can just there you can find a complete design of the beam. Thank you. If you like my video, please share and subscribe.